You run the numbers at the end of a shift, and there it is, an overall equipment effectiveness, or OEE, of 45%. It is a brutal calculation to stare down. That 45% succeeds at flashing a giant red warning light over your entire operation. But as a single number, it gives you exactly zero direction on what is actually broken or how to fix it. To stop burning through capital and shift hours, we have to pull that monolithic score apart into its 3 hidden variables. By deconstructing this formula, you can pinpoint the specific stations where your plant is leaking efficiency, turning a vague percentage into a clear list of operational targets. Mastering your metrics requires ignoring the final score and diagnosing the physical, compounding losses hiding underneath it. The first variable is availability. A solid timeline bar represents an 8-hour shift of ideal runtime, the "is it running" test. But in reality, that perfect shift is shredded by unplanned stops, delays, and breakdowns. Every time the machine goes quiet, your score drops. Tomorrow morning, bypass the catastrophic machine failures and look closely at the length of your routine setup times. That is where most plants bleed minutes. If you cannot establish a baseline of availability, your mathematical potential to hit performance or quality targets drops to 0 before the first operator even clocks in. The second variable is performance. This diagram shows 2 identical gears, representing the "is it fast enough" test. One gear hits target speeds, while the other lags behind. Out on the line, you might see heavy mechanical presses moving sluggishly. Operators will sometimes intentionally dial back the equipment. Watch the machines closely to spot the silent killers of performance, tiny recurring 2-second microstops that operators resolve without ever logging them on a chart. These specific losses are highly deceptive. The floor sounds loud and looks busy, completely masking the reality that cycle times are stretching and money is being wasted. The third variable is quality. This is the "is it good" test. Running a machine flawlessly for 8 hours at maximum speed is completely negated if the resulting products must be reworked or thrown in the trash. You spend perfectly good availability and hard-won performance to manufacture parts that possess absolutely zero market value. Tomorrow morning, ask your floor team to explain why the very first part off the line on a new shift is almost always scrap. Quality acts as the final filter of the formula. Without it, high availability and rapid performance only mean your plant is highly efficient at producing garbage. This brings us to a mathematical trap. Watch these 3 blocks for availability, performance, and quality, each sitting at a healthy 90% mark. But when we calculate the formula, multiplying these 3 90s together, the total score drops to a surprisingly low 72.9%. This steep drop explains why leadership often panics about output, even when every individual metric on the floor looks perfectly acceptable. A tiny, seemingly acceptable inefficiency in each of the 3 variables compounds exponentially, resulting in a massive hit to your total productivity. The next time the OEE plunges, use this simple checklist on this graphic to diagnose the root cause. Was the machine off? Was it running slow? Was the output bad? Drop a comment below and let me know which of these 3 specific pillars is currently causing the most trouble on your own shop floor. Because availability losses, like downtime and setup, are the most visible disruptions on a shop floor, they usually offer the most direct starting point for a recovery plan. You can begin addressing these visible gaps by standardizing your setup times. Click the video on your screen right now to learn exactly how to build standard operating procedures that help stop the bleeding. Ultimately, a metric on a clipboard is only as valuable as the physical, operational changes you make because of it.